The derivative unit. This is one of the last things you'll probably cover, and it's implicit differentiation. And this is, I would say, one of the harder parts of this unit, and a lot has to do with the notation. So what we've done so far is explicit differentiation, where we are differentiating a function with one variable. So when we are differentiating, we could use that notation dy over dx. That's the same thing as saying we're taking the function's derivative, or f prime of x. Now, if it's implicit differentiation, it's when we have a more complicated or awkward expression where we can't just find the derivative of one variable. So we have to treat it with both, and the plan is to get dy over dx by itself. So to begin with, it's just learning the notation. So we know we can differentiate this using our power rule. Right, if I wanted y prime, I would just take that 3, bring it out front, and multiply it by the 5. It would be 15x, subtract 1 from the exponent, so 2 plus, and then this next one is 7. So that is our variable, but what we want to see is showing that notation, that dy over dx notation. So instead of doing it this way, which is another way to get there, but we can say we're taking the derivative, so dy over dx, and then we're going to take the derivative of this whole expression, 5x cubed plus 7x, and this is from dx. Now, following our rules, we can expand our derivative of the binomial and expand it through. So the derivative of 5x cubed over dx plus the derivative of 7x over dx. Now that we have that, now we can actually take the derivative. So then we can say, taking the derivative, you get 15x squared. And then once you've had your derivative, you write dx over dx. Then the next one, taking the derivative of 7x is 7, then dx over dx. And here, we can't do much else, so it's just still dy over dx. Now, anything divided by itself is just 1, so then we can simplify this expression. Dy over dx is 15x squared plus 7. So as we can see, we're getting to the same place. It looks a little bit more messy, but we're doing the same thing. So we're starting with an easier example so we can see when it gets a little bit more complicated how we would do that notation. So if we want to differentiate x squared plus y squared equals 9, we'll start by saying we're taking the derivative of x squared over dy, and then we are adding on the derivative of y squared over dx. I'm sorry, this is dx over dx because it's all in terms of x. And then that will equal the derivative of 9 over dx because it's all in terms of x. Once we're at that point, then we can do what we were doing in the previous one, actually take the derivative. So if I took the derivative of x squared, it would be 2x. Once I've taken it, it's dx over dx, which we'll start to see you don't actually need to write down because that's just 1. If I take the derivative of y squared, it's 2y. And then dy over dx, so that does not cancel. And then if I take the derivative of 9, it equals 0. So now once we have this, our goal is to get dy over dx alone. So we're going to move the 2x to the other side. So you'll have 2y dy over dx equals negative 2x. Then divide both sides by 2y. And now you have your derivative isolated, and your 2's cancel, so this will equal negative x over y. But we do want our dy over dx, or our derivative, to be in terms of just one variable. So you can go back to your original equation and isolate y. So if I isolated y over here, I'd have y squared equals 9 minus x squared, and then I take the square root of both sides, and I'd get y equals the plus or minus root of 9 minus x squared. So that's what I can do at my last step, is I can replace y with the root of 9 minus x squared. And now I'm completely done, and I'm in that notation I want to see. Now, this very last one is a very challenging one because there's lots of parts to it, but we're going to still do the same thing. We wanted to figure out the derivative, and it says the equation of the tangent line through this point. So we know that if we take the derivative, we're going to get the slope, right? So still remembering that once you take your derivative, you have the slope. So if I want to start with the exact same thing we've been doing, we take a look and say, okay, I want the derivative, so d of 2x5 over dx plus the derivative of x4y over dx plus the derivative of y to the power 5 over dx, and that will equal d over dx. So now I want to go through and actually take the derivatives, but it does get a little bit messy. So for instance, if I start with this first one, if I take the derivative of 2x to the power 5, bring the 5 down, I get 10x, subtract 1 from the exponent, to the power 4. Then I want to move on. If I want the derivative of x4 times y, that is now the product rule. So I take my first term, x to the power 4, and multiply it by the derivative of y, which will be dy over dx. Then I add on my y term and multiply it by the derivative of the first term, which is going to be 4x to the power of 3. So now this part here, that's what's expanded to this part in here using your product rule. Now I keep going and I add on my derivative of y to the power 5, which will be 5y to the power 4 dy over dx, and my derivative of 36 is just 0. So I put this in brackets, but I actually don't need it. I just wanted to show where it came from, and that was that product rule. And now that I have that, now what my plan is I need to isolate dy over dx on one side and move my other terms over to the other. So let's go ahead and do that. So you would have, I'll leave the dy over dx on the left-hand side. So at x to the power 4 dy over dx plus 5y to the power of 4 dy over dx. And that will equal, so I'm done with those two, I just wrote them first, and I'm going to move these two to the other side. So subtract 10x to the power 4, subtract y 4x cubed. Okay, so I've done all that work, and now I'm just going to keep going, and I'm going to run out of room here, so I'll just go to the top. So from here, I want to notice that I have this common term of dy over dx. So I'm going to take it out, and when I do, I'm left with x to the power 4 plus, sorry, that's not how I want to take it out. I need a bracket. Let's try and get that to go away. So I have taken that out. That'll have x to the power 4 plus 5y to the power 4, and this still all equals negative 10x to the power 4 minus y to the power 4 times x cubed. Oops. Now I can isolate one more time, divide both sides by x to the power 4 plus 5y to the power 4. So I'm just going to get in here. So dy over dx will equal negative 10x to the power 4 minus y to the power 4 times x to the power 3, all over x to the power 4 plus 5y. So we get our equation, and now it's asking for the equation at the point 1 over 2. So what we can do here is find the slope. So remember that this is your slope, and if I want to know my slope at the point of 1 and 2, I can now plug in 1 for x and 2 for y. So I'm going to do that into this equation, and that will simplify to 2 over 9. Now I'm not quite done because I still need the equation of the line. So now I will use that point slope formula. So y minus y1 equals your slope times x minus x1. I know my slope, I know my point, so I'm going to plug everything in and then move things around. When you're done, you should see 2x plus 9y minus 20 equals 0. Sorry for it to get so squishy there, but I hope you found this helpful. So going through, using the rules you still know, differentiating, use that dy over dx notation, and then still going back to like that basic math of getting your slope and your point slope form. As always, I hope you found this helpful. I will have more videos coming up, including a review test from your textbook. And if you are taking chemistry, please check out my channel for other videos. Thanks for watching.